Hey guys, today we're talking about collecting and using data, or chapter 9a from the textbook. So when we're talking about collecting and using data, we're talking about making measurements, right? When we talk about collecting data, we're making measurements. We do an experiment or something and then we measure some results. So to kind of add some terminology to this process, we'll start with the word variable. So when we're talking data, our variable, that is what we, or more specifically, that is the observable thing. I'm just going to call it the observable that we are measuring. So when we're collecting data, we're measuring some variable, right? There's some observable thing that we take measurements on. So for example, if I wanted to collect data about the average size of students in a class, I might take measurements on height and weight, for example. So in that instance, the variables or the observable that I am measuring would be the height of each student and the weight of each student. So that's just an example. So first definition variable, copy that down. Next, well, we got to talk about types of data. So let's just quickly cover this. Types of data. Let's write this out as a sort of subheading here. Types of data. Okay, so our variable or our statistical, well, the thing we're measuring, the observable that we're measuring, it kind of comes in two sort of unique categories, or two unique representations. So if we're measuring something, we're conducting an experiment and we're measuring a variable, our variable could either be a categorical variable or it could be a numerical variable. So just for example, if I was talking about a categorical variable, that would be an observable that I'm measuring that is a category. So here's an example. Let's say I go into the school's staff car park and I want to conduct an experiment to gather data about the different colors of cars that teachers at our school have, right? In that instance, I'm going to be collecting data on the color of different cars, right? My variable is going to be the color of cars in the car park. That is not a number, it's a category, right? It's either going to be pink or red or blue or whatever. We're going to be measuring categories. So we consider the color of the different cars in the staff car park to be a categorical variable. On the other hand, we can have a numerical variable. This is when I'm measuring a variable and my measurements are numbers. So for example, I want to know the average size of students in the class. I'll measure their heights. I measure heights using numbers. So heights, for example, would be a numerical variable, or it would be numerical data, we might say. Okay, so we can extend even further now. So categorical data or categorical variables can be either nominal or ordinal. And we might actually just add a bit more information here. So categorical variable is a category, or variable is measured in categories. We'll just say variable is a category. Here, variable is a number. We really should, or we ought to say, is measured as a category, is measured as a number, but yeah, I think we can get away with just saying the variable is going to be a number if it's numerical data. So under numerical data, we can have discrete and continuous. So if we're looking at categorical nominal data, so if our variable is categorical nominal, well, that means we're measuring not a number, but a category. So, for example, color, month of the year, country of birth, things such as that. And it's a nominal categorical variable. Well, nominal means that there's no real order to the categories. We kind of just will nominate an answer. We'll nominate a response. So, for example, if I was like, "What country are you born in?" I'm trying to gather data. What country are you born in? And I ask some people, and they respond. They're going to just be nominating their country of birth or naming their country of birth. And there's no order or ranking system to people's country of birth. So it would be nominal. No order to variables. Ordinal. Well, you might have guessed. Order to variables. So maybe if I said, I asked you, what's your favorite size at McDonald's? Small, medium, or large? You might say medium. Well, medium is between small and large. There's an order to your possible responses. So that would be an ordinal categorical variable. Okay, discrete. Discrete means we can have only specific values. And we might say only specific values between some interval. So for example, if I'm measuring data between 0 and infinity, we could only have specific values, I might say. Okay. An example of this, if I asked you, how many brothers and sisters do you have at home? You might say 1, 2, 3, 4. You couldn't say I have 1.5 brothers and sisters at home, or 1.75 brothers and sisters at home. So there's only specific values you can respond with when we're talking about discrete numerical variables, right? So if there's only specific values that are possible, it's discrete data. Continuous, you might have guessed, all values possible, and again we might say between an interval. So for example, between 0 to infinity, all values between 0 and infinity are possible when we measure this data. So an example of continuous data, that might be height. I keep bringing up height, I know, but height, I can measure height to be 180 centimeters, 185, 185.1, or 185.01, or 185.001, right? So we can measure height to any degree of accuracy or any decimal point we want. So it would be continuous because all possible values between some interval, maybe 0 to infinity, all possible values would be available as options for measurements of height. So it would be continuous. Okay, so that's types of data. So our notes so far. Maybe we'll just kind of separate off here. Only one more thing we need to talk about. So if we are talking about collecting this data, so collecting data, well, some definitions we need to know. We need to know what a population is. This, we can kind of think about this as the sample space of responses, or sample space of people being surveyed, for instance. So population, total number of people in survey. Oh, actually, I shouldn't say in survey. I should say total number of people in question. So, like, if we want to know, how tall is the school, Applecross? Oh, I shouldn't say the school. how tall is our school? Like, how tall on average are the students at our school? Well, the population would be every student at our school, right? Next definition, a sample. This is going to be some portion of a population. So maybe I want to conduct an experiment. I don't need to ask the full population. I can just pull out a sample and survey the sample, right? So speaking of surveys, so we'll just have a quick little subheading down here, surveys. We can have census surveys. And sample surveys. Census surveys, population is surveyed. You probably have been asked by your parents some questions regarding a census that gets sent out. The Western Australian census, that would be a survey sent out to the full population of Western Australia. The sample survey, of course, this is just going to be a sample is surveyed. Okay, so why both of these exist is because there's pros and cons to either. A census survey, the main pro, of course, we're going to get most accurate information because we're asking everybody, right? So it's going to be the most accurate information we get is from a census survey. Sample surveys, though, these are going to be cheap, quick, and well, you can see that they're going to be slightly less accurate. So the census as well, this is going to be time consuming and expensive, right? So there's pros and cons to using either of these types of surveys, and it's kind of up to us if we're collecting data to decide, should we survey the population here or should we just survey a sample? But anyways, that is your notes for 9A. I'll just leave this up for a second. Copy all of that down into your books, please. Thank you.